Welcome back to the workshop and welcome back to this ongoing series to improve this drill press and add lots of extra functionality. So in this part of the series we're trying to get more room underneath the chuck, and we'll do that by creating a bit more space underneath the knee. While we're there, we'll replace this post here which is manually locked out with some kind of motorized system. So as you saw in the last video, I was looking through the motors and I don't think these ones are going to cut it. I think we need to go with a stepper. However, it does present some problems in terms of how we're going to fit it in there. So I've come up with a new plan, and it essentially involves putting the stepper motor out here in front. Now I'll redo this box so this can sit a lot lower. And what I'll then need is a longer plate, because the previous one stopped about here. And then I'm not going to have the motor adjustable, but instead what I'll do is have a couple of bearings running on a kind of an arm, and you can push that into the belt and then tension it that way. I think then that saves me trying to get all the slotted holes worked out here and having this longer than necessary. So that's the plan. So then in terms of delivering that, here's the main plate that I talked about. So I've got the material in. Aluminium's not cheap, is it? Anyway, that's what we need for the job. So that's going to be the hole there that the bearing assembly that we pressed into the old plate. I need to press that out and press it into here. Then it sits on the two blocks as before, and then you'll see the stepper motor is in some permanent holes. So I've got a couple of holes here, and there'll be a kind of swing arm with a bearing on it. It'll push against the belt, and the belt can run in that kind of shape like that and get the tension. Because that's a lot more overhang, because it's only bolted down there and there, there'll be an additional little post here, so we'll just turn a little spacer for that. So it'll be held in 3 points, and I think that'll be fine. And then there's a few other sort of threaded holes in the ends, just in case I want to put some kind of belt cover over the top, just to stop you getting your fingers caught. But anyway, that's the main idea with that one. And then here's that belt tensioner I talked about. So there's an arm here, and it will pivot about that point, which will sit on the plate on there. And then this bolt here will be for this locking bolt, and that's a slotted curved hole. That'll allow it to kind of swing like that. And then in here we're going to have a post that comes out, and there'll be a couple of bearings on it that will push against the belt. So I think we can get that out of that piece there. And then the last two parts, there's that spacer I talked about, so nothing too fancy there. Just turn this down to size, bore it and cut it to length. And then here is the kind of bearing post. So this will get pressed into that arm at this bottom end here, be that shoulder on it. And then these two bearings, these are 6,000 with 6,000 bearings with metal shields on there. And then there'll be two of those on top of there, and then there'll just be a captive nut and washer at the top just to hold that in place, stop them coming off. And that'll be the belt tensions that'll run against the belt. Got two of those. So let's make this one on the lathe, all these two parts, and then we'll get onto the CNC machine and make the rest. So the spacer was turned in the normal way, just brought the outer diameter down to size, and then put the 8.5mm bore at the centre, put some chamfers on it, and then I parted it off slightly over length. Then I turned it round and then machined off the last part through the side just to bring it down to the final dimension. So fairly straightforward there. Then it was onto the bearing pin. Okay, so here's the spacer finished off on the lathe. Nothing too fancy there, just a hole through the centre. And the important thing to get right was the length, because it forms one of the legs. So there were two bolts and two blocks at this end, and then it just gives a bit of support just at the motor end. So that part's done. And then the bearing pin down here that holds the two bearings, that's also done. So you just got a tapped M5 hole at that end, and then this was a nice fit to get the bearings to go on. And then that end was, I think, something like 10.03. I machined it in the end. That'll be a press fit into the arm, so it'll sit like that. And then the bearings, a nice easy fit on there. And then there'll be an M5 cap head on there, probably with just a washer to hold it on the inner. So I'll hold it like that, and that'll run against the belt. So there we go. That's our little guide bush. So I think next up we'll make the actual arm that piece actually then fits into. So that'll press into there like that. I've got it roughly marked out. This stock's, I think, 6mm thick, and I've called out 5 on the drawing to make sure it's thin enough to go under the belt when you sort of push this all the way in. So I'll just machine off 1mm off this, and that'll be the correct thickness, and then we'll hold it down at the edges, bore out all these features, and then cut it out. So let's go to CNC machine and get this part knocked out. Okay, so I've got the stock clamped down now on this little scrap piece of wood. I've machined that flat, so we've got a nice datum to work from. And then I've just been taking that down from 6mm to 5mm, which is the final thickness of the part. I printed the part itself out at 1:1 scale and put it on there, make sure it fits, and then we'll zero the machine in the top corner there. Yeah, and then we'll get machining. Okay, and once it's cleaned up, there it is. So that's the matte side. I think I'll have that facing up. And then that's the side I machined down to 5mm. Yeah, looks good. And you can just about see that that's a slightly curved slot there. So what I've just done, I've gone ahead and put quite a nice chamfer on there, because next thing to do will be to press this bearing pin in here. So those will go on there, and then there's a little M5 lock bolt and lock washer on there, and then that little bit there will get pressed in. That feels like it's just about wanting to go. Alright, I'm sort of tempted to do that next. Let's just make sure the bearings go on there okay. Oh yeah, nice fit. And then that will go on there. Oh. Okay, I think that's going to work. So yeah, let's do it. Why not? Let's press this into the arm. I'll take the bearings off first. I need to just make sure that goes in straight. Oh. Okay, and there's a closer look at it. Alright, so let's drop these bearings on. Okay, nice. Now I made sure that washer was quite big, just to keep some of the swarf or anything that might get down there. Although we do have the metal shield on there, but not too big, so it allows the outer race to turn. And then when I machined up the boss there, it's only touching on the inner race. And then because of that 1mm sort of top hat spacer, you can see there's space underneath that end as well. Alright, looking good so far. I've got my material in. This stuff's not cheap, so better get it right. And you can see it's nicely going to fit on there. So let's go and set this up on the CNC machine and get it cut out. After clean up and then just tapping those 2 threads in there, everything else is just a through hole and it's all ready to go. Apart from, well, 2 things I guess. The easy one, first of all, is to put the arm on there. That looks like that's going to fit okay. Quite nice fit on there. It's all lined up nicely. Okay. And then the other thing to do is, so this is the old, well, the previous motor mounting plate. I've taken this out. It was a nice gentle fit, so I was able just to push that out. But that one was a press fit in there, and I think I heated one of them up, can't remember. So I mean, rather than heat it up and press that out of there, what I think I'll just do is just cut the outside here and here, and it'll basically just fall out. Okay, so now we're going to press this bearing into the other plate that we just made, and I've had it in the oven for a little while. My wife just caught me using that. She wasn't best pleased, so we'll gloss over that. Okay, so here it is, nice and warm. Get that square. Okay, pleased with that. Seem to do pretty well. Alright, so we can start reassembling this thing. Blocked upon some wood now, so it doesn't move around so much. Okay. Oh, okay. Okay, a little bit more. Of course, the pulley that I designed and bored out to suit the other motor, which had an 8mm bore, wouldn't fit on this stepper because I think it's 6 or it might be a 1/4 inch, can't quite remember, so we'll measure it and see. But anyway, it was quite stuck on there, so I ended up using my pullers. Now, I was asked about these in one of my very old videos when I was building the CNC machine, and these are just a cheap import set from China. I've had good service out of them. People do say if you overload them, they will break on those, I assume, cast parts. Those kind of hook-shaped parts, but if you're just doing, you know, low-stress jobs like this, then they seem to be fine. I've had good service out of them. Okay, so then it's time to fit the stepper. Now that went okay in terms of mounting it on there. Just use some M6 cap head screws. I think I'll replace those with button head, just a little bit more low profile, but I don't have any in stock at the moment, so I'll put those in order. Okay, I've got the pulley sleeved out there, just turned up, I think it was 8mm OD, 6mm ID, and then I had to carefully, because there's threads in this bit, drill through and create the threads in the last bit, there, and I've got my 2 new grub screws in ready to go, so hopefully that will fit on, and then let's see how well the belt fits. Okay, so I've got our belt tensioner there. Okay, that's quite easy. Okay, looks good. Okay, so I'll put this back together. I might need to just dial in the height there. It looks like it might be a bit close, but I think that's going to work. Okay. Oh yeah, that's much better. Alright. So a little belt drive system. Nice. Okay, so I've got it back together. Belt's pretty well tensioned. Got the speed set. I'm just playing around with it off camera, and that's about the maximum speed that I feel comfortable. If you go maybe another 10% higher, it stalls out. So, you know, steppers lose torque at the higher speed, so that's fine. I'll just find the sweet spot for it and then run over that range. So, yeah, let's give it a go. In quite nicely. There we go. And in terms of torque on here, I can't make any difference. Oh no, I've got it there. So I think we'll be okay with that. If we do have any issues, this will go up to 50 volts, so I could probably find, you know, I don't want to go quite that high, but I'm only running about 27 or 30 at the moment, you know, so I could go to sort of 45 or something like that, and that would give it a lot more torque as well. But yeah, pleased so far. Let's just check the limits. And down. Okay, progress. So I'm pleased to have got that finally working. Sort of 3 steps forward, 2 back with this project, but that's how they go. Yeah, so I think that stepper was a good choice. It's going to be plenty powerful enough to lift this. I'll have plenty of control. Got lots of options available now using the stepper system and the driver. So I think that's enough for the electronics and this hardware side. Next time we need to get onto the drill press itself, start stripping it down, modifying some of the bits so we've actually got more travel on the quill, and then we can get this embedded. So if you're enjoying, feel free to subscribe, and with that, I'll see you next time.